Video I want to look at the lesson similarity and similarity transformations, and I want to start with the summary. It's always a good idea when you take notes to include the information that's on the summary. The idea of similarity is applied to many practical situations involving geometric shapes such as design of wind chimes discussed in the lesson. In geometry, the word similar, and you do want to write this down, means having the same shape but not necessarily the same size. Formally, you also want to write this down, two shapes are similar if there exists a combination of rigid motions and dilations that can map one onto the other. That means that the two match exactly, overlapping each other exactly. Sequences of rigid motions and dilations are called a similarity transformation. The other property about similarity that you need to know is that if two figures are similar, it means all pairs of corresponding lengths in the pre-image and its image under a similarity transformation are all in the same ratio, and all pairs of corresponding angles have the same measure. For example, suppose we're looking at this triangle and this smaller triangle. And suppose we're told that they are similar. What that means is that all three of their corresponding angles are congruent. So this angle is equal to itself, of course. So we know that angle's congruent. But this angle is equal to this angle, and this angle is equal to this angle. It also means that this side is in proportion to its corresponding side. So suppose this larger side has length 10 and this side has length 5. That tells you that the ratio is 2. If you multiply a side length of the smaller triangle times 2, you get the side length of the corresponding side length of the larger triangle. So that tells you that if this side has length 3, this side has length 6, and if this side has length 4, this side has length 8. That's what it means for two triangles to be similar. Corresponding angles are congruent and corresponding sides are in proportion. Now, the definition of similarity in terms of similarity transformations means that you can perform a series of rigid and non-rigid transformations to map one triangle onto the other. And keep in mind, rigid transformations include translations, rotations, and reflections, and rigid transformations do not change side lengths or angle measures of a figure. And non-rigid transformation is a dilation. Dilations preserve shape but not size. So a dilation will preserve angle measures but not necessarily side lengths. Now let's look at some problems from this lesson. Polygon ABCD is dilated, rotated, and translated to form polygon A', B', C', D'. The endpoints of segment AB are at 0, -7, and 8, 8, and the endpoints of A', B' are at 6, -6, and 2, 1.5. What is the scale factor of the dilation? In order to find the scale factor of the dilation, you need to find the length of these two corresponding segments. Since ABCD is transformed to become A', B', we know that side AB multiplied by the scale factor will give us side A', B'. So if we find the length of side AB and plug it in for AB here, and find the length of A', B' and plug it in here for A', B', we just need to do a one-step equation to find what n is, the scale factor of the dilation. So we can go ahead and find the length of side AB using the distance formula. We know that AB has endpoints here. Distance formula, D equals the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And you do want to memorize the distance formula. So let's plug in the points. Let's call this point 2 at 8. So x2 is 8 minus x1 is 0. Quantity squared plus y2 is also 8 minus y1 is negative 7. Quantity squared. And we'll simplify. 8 minus 0 is 8. 8 squared is 64. Plus 8 minus negative 7. Change subtraction to adding the opposite. And then follow your rules of addition. So 8 plus 7 is 15. 15 squared is 225. 225 plus 64 is 289. And the square root of 289 is 17. Now let's find the length of A prime B prime using the distance formula. x2 minus x1, 2 minus 6 is negative 4, quantity squared, plus 1.5 minus negative 6, quantity squared. Negative 4 squared is 16 plus 1.5 minus negative 6 plus positive 6 is 7.5 quantity squared. So we'll just use our calculator for that. 16 plus 7.5 quantity squared equals 72.25. And the square root of that is 8.5. So we'll plug 8.5 in for A prime B prime and 17 in for AB to find N. So dividing both sides by 17 is 0.5 or 1/2. So you can just enter 0.5. Now let's look at another problem. There exists a similarity transformation that maps triangle ABC to triangle A prime B prime C prime. The measure of angle A is 68 and the measure of angle B is 46. What's the measure of angle C prime in degrees? Okay, in order to solve this, you need to know, because there exists a similarity transformation that maps triangle ABC to triangle A prime B prime C prime, this means that the triangles are similar. So because the triangles are similar, you need to know that that means their corresponding angles are congruent. And you also need to know the triangle sum theorem, which states the three angles of a triangle sum to 180 degrees. So that tells you angle A plus angle B plus angle C equals 180 degrees. So therefore we know angle B and we know angle A. So if we find angle C by solving this equation, we will also have the measure of angle C prime because corresponding angles are congruent. So let's plug in our known values into this equation. Angle A, 68 degrees, plus angle B, 46, plus angle C equals 180 degrees. So we'll subtract these two values from both sides of the equation to get angle C, 180 minus 68 minus 46, and you can use a calculator. And you get 66 degrees for angle C and also for angle C prime. And of course you will only enter 66 in this field.